All right, in this video, we're going to spend a few minutes to talk about some basic Java and get us to the point where we can create a very simple Java application so that we can begin working on our assignments for the week. So the information we're going to cover is from chapter 2, so I suggest that you spend some time reading that chapter as well as watching this video and following along with the examples that will be posted after this video. This is what a basic Java program looks like. In our class, we're going to be writing Java console apps. This means that the app will be running in the Java REPL, which is a Java programming and execution environment. We're going to be using a tool called JDoodle, jdoodle.com to do that. And in a console app, everything that we need is every Java program is going to have these 4 lines in it. We're going to have to define a public class. We're going to give it a class name. Inside that class, we're going to define a public static void main method, and it's going to have this parameter string, an array of string named args. And then inside this public static void main, we're going to put our statements. This is where the logic is going to be that does the work that we have. Also note that each one of these blocks, this is a block, this class is a block definition, this public static void main is a block definition. We'll be seeing other block definitions as we create other data structures, if statements, loops, and things like that. So, but every block is defined with an opening curly bracket and a closing curly bracket. The placing of these brackets is important. The opening curly bracket goes at the end of the line where the block is defined. This is the definition, public class, class name. This is the definition of a class named class name. This is the opening block, curly brace. This is the closing of that block. Notice how they're lined up. The closing block is lined up with the beginning of the definition. The opening block is on the same line as the definition at the end. We see the same thing with the curly braces here on the public static void main. Opening block, curly braces here. Closing the block, curly braces here. Okay. This is what this is an example of what our statements are going to look like inside our public static void main. We see this as a system.out.println. This is just going to write some kind of text or data to the console so that we can see it. So this is a fully executable Java program. If you were to type this into your JDoodle REPL, you could run this and you would get this output. Notice that we've actually named the class here instead of calling it class name. Here we just had class name, which was a placeholder. Here we've actually named it test app. We could name this my program. We could name this rectangle solver. We could name this contact program, whatever you want. Something that is relevant to the problem that you're trying to solve is what you should use. Okay, so when we name a class, we want to start every word within the name with a capital letter. This is called upper camel case. So we can see that the first letter of each word is uppercase and the rest of the letters in those words are lowercase. That's known as upper camel case because it starts with an always starts with an uppercase letter. We're going to use only letters and digits, and preferably not even digits, really just letters that we need. And then the name of the class, if you're not using jdoodle.com, the name of the class must match the name of the Java file. So if you're using a Java IDE on your laptop or on your computer, you're going to want to make sure that the name of the Java file that you're writing the code in and the class name are the same. JDoodle is going to be a little more forgiving than that, but we're going to continue to follow that nonetheless. Okay, we also will create statements that will hold data because our program needs to create data. It needs to collect data from the user, needs to do operations on that data, and then print that data back out with some answer or some solution to the user. So the data comes in what we call data types. There are 8 primitive data types. We're going to start using 2 right away. One is it called int, and one is called double. Int is short for integer. An integer is a whole number, 0, 1, 2, 3, 4, 5, etc. That is positive or negative. And int is a data type that will allow us to use those integers. It does have an upper bound. There's also int a long integer, int 4, int 8, int 16, int 64, etc. So Those are just define the upper and lower range of the int. For what we're using, int is going to be just fine. This will hold all our numbers. We're going to be using numbers, fairly small numbers, so that won't be an issue. Double is a data type that allows us to have decimal precision. So 1.25, 3.14, things like that. We'll define those using the double data type. Notice these are lowercase letters, int with a lowercase I, and d with a lower or double with a lowercase d. These are Java reserved words. They're primitive data types, and so as a result, we're using lowercase letters. If and we'll see in some other situations where we'll use uppercase to declare data types. In that case, we're not declaring them as primitive data types. We're actually declaring them as we're using instances of classes that are built into Java. So that will make more sense as we get into it. Here's an example of how to declare a variable and assign a value. So this is the declaration. You say what the type of the variable is, int double, and then you give it the variable name, and then you can assign it a value. So this is a definition, int counter, and this is an assignment, counter equals 1. The equals here is an assignment. It does not test for equality. This is saying that whatever is on the right side of the equal sign, I'm going to evaluate this right side, do the calculations. I'm going to assign it to the value of the variable on the left side of the equal sign. So this means that counter is going to equal 1. So once the statement runs, counter will have a value of 1. When I define counter, it's going to be defined and initialized to the default value for that data type. In this case, since it's an int, it will be 0. So when this statement runs, counter has a value of 0. After the statement runs, counter will have a value of 1. You can declare and assign the value all at once in the same line if you want to. You should note that you can only declare the variable one time. So once I've declared int counter equals 1, if I want to assign counter, say I want to assign counter a value of 10, I will leave the int out on subsequent uses of the counter term. So I'll only declare the variable a single time. If you try to declare it more than once, you'll get an error when you try to compile your program. This is a declaration and an assignment all in one statement, as we see here with double. And when you are declaring doubles and using doubles in what we call literals, this is 14.95. This is a literal double value. You're going to want to always make sure that you use the decimal point with some precision. So if you're going to assign unit price of 14 even, since it's a double, you're going to want to assign that to 14.00. You can also let Java pick the type the type of the variable using this var um, reserved word, this var instruction. In this case, the Java compiler will set the data type of this variable counter to whatever it infers is the data type of the expression on the right side of the equal sign. We're not going to do this for now. We will use this later in the class and once we get a little more experience. But for now, we're always going to be explicit about defining our data types. Always use int or double or string or whatever we're using. That's good practice at this point for you since you're new to this, to be really clear and explicit about the data types that you're using. Okay, when we name variables, just like when we name classes, we have some rules. So for variable naming, we're going to use a lower camel case. Notice how in this case we have a lowercase u, and then lowercase letters in the word unit, and then an uppercase p, and lowercase letters in the word price. This is called lower camel case because it starts with a lower, and then it camels it alternates between lower and upper at the beginning of each word. So we want to use always start with a letter using lower camel case. There are some Java keywords that we cannot use to define variables. Things like class. Class is a Java keyword. Main is a Java keyword. We cannot use those words to define variables. So this is a quick list. Usually this is not a problem. These are not words that we're going to be using a lot in our code anyway. So, but these are all any Java keyword you cannot use. So we see things like char, else, final, switch, while, throws. These true, false. These are built-in Java statements to their Java keywords, so they tell the program what to do when used in context properly. And so we cannot use any of these to define variable names. You don't have to worry about this. The IDE that we'll use to write Java code usually is pretty good at telling us when we're making a mistake like this. So this should not be too much of a problem. Okay, up camel case notation, always start with a lowercase letter and use meaningful names. You don't want to define your variables as A, B, C, or X and Y unless X and Y are in have some kind of context in your program. You always want to use things like counter, quantity, invoice total, first name, last name. These are descriptive names that will help you as you try to read the program, will help you understand what the program is trying to do. So we will use things like I and J and X and from time to time, but those are typically used where the name of the variable doesn't really have any context in the program. Iterations, while loops, for loops, things like that. And so in those cases, we will use those short, 1 or 2 letter names, but we will typically always use a variable name that has some meaning in the context of the problem our program is trying to solve. In addition to assigning data types or values to variables, you can also do math. So we have some basic math, plus, minus, addition, subtraction. The asterisk is used for multiplication, and the slash is used for division. These are some examples of arithmetic functions. Here we define a variable named x and a variable named y. They're both of integer data type. This x is assigned 14, y is assigned 8. We can then define a new variable, result 1. It's going to equal x plus y. This now means that result will be equal to 22. X minus y, result is equal to 6, multiplication, divide, etc. Notice in this, when we do the divide, we say 14 divided by 8. Notice that will yield a decimal value. Okay, because 14 is not evenly divisible by 8, even though our result here is saying 1. That's really going to be 1 point something. But because we've defined result 4 as an int data type, we're getting truncation on the decimal portion. Truncation means it's just being cut off. So we will not actually get the decimal precision here. And so if you use this, if this matters in the math that you're doing in your program, this would yield an error, a logical error. Your program would yield incorrect output. We can do the same with double values, and you see that we're carrying the decimal precision as we go. And here we get 8.5 divided by 3.4, and we're actually getting the decimal precision that we're looking for. Okay, we can also do increments. We can assign a variable to itself plus math. So in this case, we define invoice count. And then we define invoice count equals invoice count plus 1. This is essentially adding 1 to the value of invoice count. When you do this, we evaluate the right side of the assignment statement. Remember, this is because it's an equal. This is an assignment. We're evaluating the right side. We're assigning it to the variable on the left side. The evaluation goes first. So invoice count is 0. We then add 1 to it. And then we take that value, which is now 1, and we assign it to invoice count. The assignment takes place after the evaluation. And so here it goes again. This would be invoice count would yield 2. So we always do the evaluation on the right before we do the assignment to the variable on the left. Here's some more examples of adding. We can see we can use literal values, or we can use all variable names. These are mixing data types. In this case, we have a double value. Result 9 equals invoice total divided by invoice count. Invoice total is a double value. It was defined back here. Invoice count, this is an integer value that we defined here in this previous example. So when we're mixing the data types here, you're going to have to make sure that your resulting field, that your resulting variable has an acceptable data type. This is going to yield, when you take a double number with decimal precision and you divide it by an integer, you're going to get a double value. It's going to yield a double value that has decimal precision. So you want to make sure that you're storing that in a variable that has an adequate data type. You can also cast them. So in this case, when we're using the int, we're saying take the invoice total and convert it into an integer. In this case, it's just going to truncate the any decimal values and then divide by the invoice count. So invoice total here, we could see is the invoice total plus the invoice amount one. So we have these values. Invoice total is 251 here, perhaps. But when we convert this, we're going to just chop off any decimals because we're using this casting to an int. Same thing when you cast here to a double. This is a widening cast. So in this case, we're just going to add decimal precision to invoice count, which then will help us yield uh, a, a result from our arithmetic function that has decimal precision. Okay. So it's really important that you pay attention to this when you are doing math. You want to make sure that you have defined adequately the data types, int or double, so that you don't get truncation or incorrect rounding errors on your results. So generally, if you're going to be using a double value, you should use all double values. Or you should at least make sure that you are doing this cast when you do the division. When I say cast, this means we're taking this invoice count, we're casting it into a new storage data type. Invoice count is an int. We're casting it into a double. So we're going to say, I want to take invoice count, I want to convert it to a double, and then I want to do the math. Okay. In this case, we're not actually storing this value, this casted value, in a new variable. We're just using it as part of the execution of this evaluation statement. Here's another data type. This is not a primitive. You can see that we're using an uppercase S for string. String is us just using alphanumeric data. So if we want to store words or descriptions or prompts for the user, things like that, we're going to use a string data type. We use uppercase because string is actually a higher level class that's built into Java, which is why it's using an uppercase letter, unlike int and double, which you're using lowercase. Okay, and we'll see some uppercase things as we go. Anytime you use a literal value for a string, you want to include the literal values in double quotation marks. So double quote at the beginning, double quote at the end. Everything that's in between those double quotes is the value that's being assigned, in this case, to message one, and then of course semicolons at the end of every line, which we've seen on every example. There's always a semicolon at the end of every line. You can do what looks like math on strings using the plus uh, 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 statement here. And so but when you use plus on numeric data types, we get addition. When we use the plus operator on string values, we actually get concatenation, which means we're taking those strings and we're putting them together, just appending them to each other in one string. So we can see that we've defined first name as Bob's, last name is Smith. And then when we concatenate them, name equals first name plus a blank space plus last name, it now looks like this, Bob Smith. So this is concatenation. If you attempt to concatenate with a mixed data type, in this case, this is a string and price is a double, you will yield a string. So in this case, price will be automatically converted to a string value, and then it will look like this. Okay. So anytime you try to use the concatenation operator on numeric data, it's going to automatically convert that numeric data into a string. Here's more examples of concatenation and appending. Sometimes in strings, you want to have special characters. These are in order to do that, you use these escape sequence. This is a new line value that will basically put a carriage return or a new line into our string value. This is a tab. This is another new line. This is if you want to include the actual quotation mark as part of your string or the slash as part of your string, then you can use these escape characters to do that. Here's some examples of those. Okay. Oops, I went the wrong way. Here's some examples of those. Here's Joe Smith, new line, Kate Lewis. It will yield this result. This is one string. It looks like two, but it's one string with just a new line in the middle, meaning that it's essentially it's a character turn. It's like pressing enter on a keyboard. Here we get a tab statement and the new line. So this is just a tab that's in the output. This is us putting quotation marks. You can see that we're using the escape value with the slash. This is the slash the other direction than the divide symbol. Make sure that we're using the forward or the backward slash appropriately. Okay. All right. So that's a quick introduction. We're going to do a couple of examples. Each of these examples will be in a separate video, so watch those and follow along with them as much as you can.